I'm going to go over how to graph logarithmic functions. So there's about 3 examples that we'll go through. Okay, so here we are with example 1. F of x equals log base 2 of x plus 1 minus 3. In the left side over here in the table, we were talking about our reference points. You can recall that the first reference point the reference point will be 1, 0. And then our second one is our b, comma 1. So this 2 that you see here in the reference point is coming from the base in the problem, in our function. In the top gray area, the x, I'm going to go ahead and put in here what affects each one of these variables. So when we go to create our new reference points, it's kind of handy. So x is going to be affected by our h value. So x is going to be affected by a -1. So it'll be x minus 1. Our y will be affected by our a value. Currently, there's not an a other than a 1 in front. So we have a 1 times your y value, and then your minus 3, which is your k, will be affected. So let's get started. We have 1 minus 1 equals 0. You have 1 times 0 minus 3 equals -3. Then you have 2 minus 1 equals 1. And then you have 1 times 1 minus 3 equals -2. So that means our new reference points that we're going to actually put on our graph will be 0, -3 and 1, -2. For our vertical asymptote, remember we talked earlier, x equals our h value. So in this case, x equals -1. Describe the transformations. I like to go from left to right when I'm describing the transformations. So out front, there's no a value that's going to make a change. So then we're going to go to our h, and our h value has a -1, meaning that we have a shift left 1 unit. And then we're going to shift down 3 units because our k value is -3. So next, let's talk about graphing. I'm going to go and take those reference points and put them on the graph. We have 0, -3. There's the first one, and 1, -2. Next, go ahead and sketch our vertical asymptote at x equals -1. So we're going to go to -1 and put it where it crosses, and then I'm going to go ahead and create my dashed lines vertically for my vertical asymptote. And as you're looking at this graph, you can see from left to right that the first point that you look at is lower than the second point, meaning that this particular graph is going to start at the bottom, go up and to the right. So I'm going to show you, I'm going to draw it kind of close. Make sure you're close to your vertical asymptote. You're going to curve around and just kind of keep going to the right. And then make sure you put your arrows on both ends because it does continue in both directions. So at this point, all we have left to do is our domain and range values. Domain, don't forget, is your x. Range is your y values. Looking at our domain, it is restricted going to the left by the -1 of our vertical asymptote. So it's -1 to positive infinity because you can't touch either of those, though we're going to be parentheses. Some of you might also say that x is greater than -1. Then our range, remember it goes from the bottom to the top on our y values. All of our y values in this case are going to be from -infinity to positive infinity, or you could say all real numbers. All right, here we are with example number 2. Our given starting reference points are 1, 0, and 10, 1. We know that the 10 is coming from the base from the problem. In our function, it says f of x equals -2 times the log of x plus 5. Although there's not a 10 here written for our base, we can understand that we've talked about it before, that would be a 10. So that's where that 10 is coming from in the reference points. So to talk about the new reference points, we know x is affected by h. So that would be x minus 5. And then we know our y is going to be affected by our a, which is -2, times our y value. In this case, we don't have a k. It's out here to the side, and that would be like a +0. We don't have to write it, but if it makes you feel better, you can. So let's get started. 1 minus 5 equals -4. -2 times 0 equals 0. Then we have 10 minus 5 equals 5. And 1, oops, I'm sorry, negative 2 times 1 equals negative 2. So our new reference points are going to be negative 4 comma 0 and 5 comma negative 2. Our vertical asymptote is our x equals our h value. We know our h is negative 5, so x equals negative 5 for our vertical asymptote. The transformation, I like to do those from left to right. There's a negative sign out front, so that means it's going to reflect over the x-axis. And then we know that the 2 is greater than 1, so that means we have a vertical stretch. And I always make sure that you need to put vertical stretch by 2. And then you have a shift. In this case, it'd go left because our 5 is positive, so it's actually moving left 5 units. Perfect. So that's our transformation. Now at this point, you notice again that I have not even looked at the graph. I don't know what it looks like. I'm just going based on the function and the information that's given to us. Let's go to our graph and put our reference points. We have negative 4, 0, and we have 5, negative 2. And then we need to go ahead and do our vertical asymptote. Our vertical asymptote is at negative 5, so we're going to go over to negative 5 and put our little dashed lines all the way from one side to the other. Now, don't forget that this function was reflected over the x-axis. So if you look at this graph going left to right, you'll see how the point on the left is higher than the point on the right. So that means it's going from the top, going down and to the right. So let's go ahead and graph that. I'm going to start at the top, kind of come down. It'll do a quick shift to the right and keep going. There we go. So there we go. We can visually see our sketch. Obviously, it could look better, but yeah, it's fine. So on our domain, let's go ahead and answer our domain and range questions. For domain, looking at this, remember we were restricted going to the left by the vertical asymptote at negative 5. So we'll have negative 5, all the way to positive infinity. So parentheses, parentheses, or you could say x is greater than negative 5. And then for our range, we have negative infinity to positive infinity. And then we could also say all real numbers. So here we are with our example 3 on our video. This will be the last example. We're working with the function f of x equals 3 times a log base 1/2 of x plus 4. Now when you're looking at this, please make note that the 3 is going to be your a, that 1/2 is your b, your base. Now notice the plus 4 is not inside of a set of parentheses with the x, so this plus 4 is actually going to be a k. If it was an h, then the h would be with the x inside a set of parentheses, and that would kind of set it apart from the k. So just keep that in mind. When we go do our reference points, remember that h value is affecting the x, and in this case we don't have an h value other than 0. So whatever x is will stay. If you were to add 0, it's going to stay as x. Now y would be affected by the a, which is 3 times your y, and then plus 4 for your k. So 1 will just stay as 1. 1/2 will stay as 1/2. 0 times, so we have 3 times 0 plus 4 equals 4. You're going to have 3 times 1 plus 4 equals 7. So our reference points that we're using are 1 comma 4 and 1/2 comma 7. Now our vertical asymptote, remember, is x equals h. We don't have an h value other than 0, so it is x equals 0. To describe the transformations, we are going to start off at the beginning with a being 3, so that means we have a vertical stretch. And make sure that you mention what that value is. So vertical stretch by 3. And then we know the only other change here would be our k, so we have a shift up 4 units. Let's go ahead and put our points on our graph. The first point is at 1, 4. And then the next point is 1/2 all the way up to 7. So it's right in this little area here. Let's go ahead and do our vertical asymptote at x equals 0. And we're going to go right next to the axis. I don't like to put it on top so that you can still see it and have an idea where you're at as far as graphing is concerned. So I'll do it right out beside it as much as possible. And that way gives you a better visual. All right, so then I'm going to go ahead and notice from left to right that point, the first point is higher, the second point is lower, so it's coming from the top, going down and to the right. So looking at our domain, looks like our domain is being restricted by the 0. So we have 0 all the way to positive infinity, so parentheses, parentheses, or x is greater than 0. Then you have range, which is going to be all real numbers or negative infinity to positive infinity, or all real numbers. All right, so some of you might realize by looking at the graph that this graph is going from the top down to the right. However, it didn't reflect at all on the x-axis. So what happened is this base is 1/2. So the base is 1/2. And if you recall when we did exponential growth and decay, when we had a base of 1/2, it was an exponential decay. So this is sort of mimicking that same idea.